Welcome everyone to the Xojo webinar. I'm Paul Lefevre, the Xojo Developer Evangelist. And our topic this time is Advanced SQLite. So before we dive right in, do a little bit of background about SQLite itself. It's an open source database. It is very lightweight, which makes it quite popular. It is what is called an embedded database, which means it doesn't require a separate server or anything like that. The database code is embedded into the app that uses the SQLite database. According to the SQLite website, SQLite is now the most widely deployed database in the world, which isn't too surprising because it is so lightweight and embedded. Just about any app can easily use a SQLite database for something or another. You could use it for simple things like storing preferences. You could use it for more advanced things. It's built into mobile phones, operating systems, most of the apps used by those things, so quite common. The official website is at SQLite.org. And you can access SQLite from within Xojo using one of two classes. You can use the SQLite database class for desktop, web, and console projects. And for iOS projects, you use the iOS SQLite database class. Now, I'm not going to go into the specifics about how those work with Xojo or anything like that. We're going to be covering more general SQLite features. We'll talk about Xojo a little bit throughout this, but nothing too specific about these classes. Generally, the two database classes here work largely the same. A few minor syntax differences here or there, but nothing really earth-shattering. All right, so what are some of the features we're going to cover? Well, the first thing I want to talk about is going to be write-ahead logging, also known as WAL. We'll briefly talk about an in-memory database and what that is and why you might want to use it. Triggers, the Pragma Statement, foreign keys, full-text searching, indexing, and lastly, how you can use blobs. So the first thing, write-ahead logging. What is this? Well, this improves the read-write performance to disk. Normally, when you use SQLite and you make changes to your database, this writes to the disk two times. Once to the actual database file, and then once to a rollback file. And obviously, writing to a disk twice is more expensive than writing to the disk once. So if you enable write-ahead logging, this kind of switches it around so that rather than writing the change to the main database file and then to a rollback file, the change just gets written once to what's called a WAL file. And then SQLite internally manages which is the current data that's in the database. You can read a bit more about this in the Xojo user guide. There's a section on this. And there's a few different ways you can enable it. If you're just using SQLite yourself or through some tool, you can use the journal mode Pragma to turn on write-ahead logging. And if you're in Xojo, you can just execute that Pragma using the SQL execute command. Or you can just set the property that's on the SQLite database class, which is called multi-user. Actually, looks like I got a typo there. It's not multi-user, it is multi-user. I got new glasses a couple days ago, and now I can see things like this. But you can also set that property if you want. Now, are you always going to want to turn this on? Maybe, maybe not. For desktop apps, you'll probably want to test to see if it really is worth it and if it makes a difference. Because WAL is going to end up creating a different set of files on your drive. And it may or may not matter depending on how your transactions are set up. And it may or may not matter because often desktop apps are single user. So only the one app is writing to the SQLite database at a time. So there's not a lot of contention or reasons for the write to need to happen, just a lot faster than it might otherwise. But if you're working with web apps, you probably are almost always going to want to turn on write-ahead logging. And the reason is web apps can have multiple users connected to them doing things. And if your web app is using SQLite, multiple people that are connected to the web app may be making changes that require updates to the database. Now, the single web app itself is the one connected to the SQLite database. You don't have multiple users connected to the database, really, but you do have a lot of updates happening to the SQLite database. So you're going to want those to happen as quickly as possible. And in that case, flipping on write-ahead logging is the way to go, so that if multiple users are connected to the web app and are making changes that are writing to the database, those changes will just get written out as quickly as possible without causing any delays in your web app. All right, now in-memory database. Essentially, an in-memory database is, like you might think, it's a SQLite database, but it's not pointed to a corresponding file. Now, why would you want this? Well, it can actually be a useful way to have temporary high-speed data lookup that allows you to, use SQL to get at stuff. So maybe you might find it useful for a cache or something like that. They're really easy to set up because essentially you just create your new SQLite database and you just connect to it. You don't have to assign a file or a folder item to it to point it anywhere. You just do this, and now you have database in memory, and you can do what you need to do. You could, you can start. Obviously, you're gonna have to create a table, but you can create a table. You can insert a bunch of data into that table. Maybe you're getting that data from elsewhere. Maybe a data file, a JSON file, or something like that, and you want to pull all that in, quickly throw it into an in-memory SQLite database using some particular structure that you want. And then all of a sudden you can just use that in-memory database to query that data that perhaps used to be in a different format. And as you know, if you've worked with SQL, that can be a nice way to pull information out that might otherwise, maybe require you to be writing code that's doing a bunch of looping and string comparisons or stuff like that, which may not be as efficient as just quickly copying up all the data into the in-memory database and then using SQL to pull it out. So that's a pretty useful feature that you can take advantage of. It's not entirely obvious because it's not like there's a specific property or setting where you are saying, oh yeah, I'm using an in-memory database. You just essentially, you create the database and you connect to it, and now you get an in-memory database. All right, well, on this topic, Marcus has a question here. It says, can you use write-ahead logging with an in-memory database? I'm not sure. You probably would have to check the Pragma and maybe even lower level SQLite docs to see if that makes any sense whatsoever. I don't have the in-memory database specifics memorized, but they talk about where situations where temp files might be used and other stuff like that. But I just can't imagine normally that there would be any difference because it's all in memory, so it's not like you need to speed up the writing of the data versus when you go into a drive, that can matter. So I wouldn't expect really any difference, but without studying the SQLite docs more carefully, I don't know for 100%. All right, moving on to triggers. Triggers are SQL code that runs when table data is modified in some way. Now this can be that you're inserting data into a table, you're updating data in the table, or even if you're deleting data from a table. And these are on the SQLite database, so they don't require any code in Xojo or any other tool to use them. They're just on the database. And they're useful for a variety of things. Common thing you see triggers used for is like logging or auditing. because when there's a trigger on a table, it will run every time the table data is modified, depending on the type of trigger you've created. So anything that changes the table data, whether it's a client app or someone monkeying around directly in the data using a database tool, the trigger will still get called, and it'll be able to note the change, maybe update a different logging table that says, this row was modified on this date time. It could, save the changes, save the old values, whatever you particularly want it to do. So that's a common use for triggers. And you can also use it for updating related columns or tables. So we'll look at an example a little bit later of a trigger that almost functions as a computed column, so to speak, where it's going to take two other column values, and anytime one of them gets updated, it'll update a third column value with the concatenation of those two. So that allows you to have almost like a computed column, so that you don't have to have maybe code in your Xojo app that's combining stuff like that. It's more automatic and on the database level. So those are a couple use cases where these sort of things can be helpful. That's the official page on the SQLite, or the official doc page on SQLite, that you can read more about that. Then this here is an example of what a trigger can look like. This is an update trigger, and you can see you just give it a name, and this particular trigger will run whenever the last name column that is on the customers table gets updated. And when that happens, it runs the code that's between the begin and end. And because this is on the SQLite database, the code that's in here has to be SQL, of course. It has to be SQLite supported SQL. So when the last name column is updated, it's updating that same customers table and setting another column called full name to be the first name and then a space and then the last name. And it's doing that for whatever the row was that was modified. So if you happen to modify a bunch of rows in the table and you change a bunch of last names, this trigger will get run for each row so that everything will get updated accordingly. And there's a lot of different ways you can have triggers. You can have triggers that run before something gets updated, after something gets updated, on, like I mentioned above, on insert statements and delete statements, as well as update statements. And you can have multiple triggers on your table, of course. So, if you wanted to also create a trigger that was an insert trigger, so that anytime a new row was created, the full name column is also populated, could absolutely add that, and you could have both of these triggers sitting on the table. Really, the limit is your imagination on how you can use these things. You don't want to go too crazy, of course, like anything else. If you have a ton of triggers in your app, it's going to kind of be changing the data on you, not in an obvious way, right? Because it's going to be running this trigger that you may not normally be thinking about. So if you do have a ton of triggers, that can get a little tricky with debugging. You want to pay attention to that. Obviously, you can't step through them in SQLite, so you have to be cognizant of that. So, when used carefully, they can be quite helpful. William is asking regarding triggers, can you change something in a different table or even a different database? You can totally change something in a different table. You don't have to change something in this table. As an example, the logging that is often used, I could have a separate, customer logging table. And then anytime columns I care about on the customer table are updated, I could or maybe insert a row into the customer logging table that has, the name of the column that was changed and the date or something like that, whatever I wanted to log. But yeah, you can totally update different tables. As far as updating different databases, SQLite does let you connect databases using the attach command, but I'm not 100% sure if the triggers will work across that or not. I have not tried that. So you definitely want to head to that SQLite doc page to see if that's something that is supported in SQLite or not. Kind of seems like it might be, but then if you don't attach the database beforehand and your trigger tries to run, you think some sort of database error might be raised. So I don't know specifically, but that's worth a little bit of research. Let's see here. Steve is asking, does entirely separate trigger need to be created for the first name modifications in my example? Yes. A different trigger would need to be created. Here I have a trigger that is just checking for updates to the last name column. And if the last name column is changed, then I'm updating the full name column with both the first name and the last name. But if I want to make sure that that's updated if the first name is changed, then I need a separate trigger that's update on first name to add that. And Edwin is noting that triggers are also very useful. I didn't include it specifically here, but you can also use it to delete data. So if you have tables that are related in some manner, and maybe you have a parent table where something gets deleted, you could actually use a trigger to make sure that children in other tables have their data removed as well. So lots of uses for triggers that can be very helpful to make sure your data stays, the way you want it, doesn't get all messed up, anything like that. And before I move on to the next one, Edwin is also asking about the pipe characters that are after. If you look at the SQL, after where it says first name, there are 2 pipe characters, and those are the concatenation characters in SQLite. So that would be equivalent to like using plus for text or strings in Xojo. All right, we're going to now move on to Pragma. And Pragma statements are commands that you can run that change how SQLite works. There's a really long list of them at this page on the SQLite docs. And most of them you're probably not going to use, to be perfectly honest. Some of them are kind of fun to look at and play around with, but you're probably not really going to monkey around with a lot of this stuff. But there are a couple that I tend to use, and I'm going to call those out specifically. The first one is user version, and the second one is foreign keys. And to set or read Pragma values, you just use them like this. So if I want to assign a value to the user version Pragma, I just can say Pragma user version equals 4. And in Xojo, I could just send that along as a SQL execute, as standard SQL using the SQL execute command. The foreign keys Pragma that's underneath enables foreign key support in SQLite, which is not turned on by default. We'll look at that in a moment. Now, if you wanted to check the value of these, you can just type Pragma user version, and that will return the result. And in the case of Xojo, that would essentially function as if it were a select statement. It'll return a record set with that value that you can then read and see what it is. Now, what is user version useful for? User version is great for, wait for it, tracking the version of your database. So in particular, if you happen to have an app that's out there in the wild, odds are over time, you're probably going to need to modify the database schema or design. Maybe update a table with a new column, maybe add an all-new table, that sort of thing. Well, it can be very helpful to have versions assigned. So you can put the first version of your SQLite database out there, call it version 1. And then if your app needs to update, you can have scripts, essentially SQL scripts embedded in your app that you can run. So you can check the version when the app starts up, and it can say, what's the version of the SQLite database? Oh, it's still at version 1. Well, I have a version 2 script. I'm going to run that. And then that, after it's finished, will update the user version to version 2. And you now know your database is updated. And the beauty of that is you can kind of just do that recursively, and then after you update it once, you can check it again and say, what's the version now? It's 2. Do I have an update to 3? If so, you can get that script and run it. So it's incredibly handy to just maintain a version of the database that's actually tracked within the database itself, so you don't have to store it elsewhere in a preferences file or something like that where it could possibly get out of sync. So I have used that one quite a bit in the past. And then, of course, foreign keys, which we are going to transition to here in just a moment, are also quite useful. So let's talk about foreign keys. All right, and before we dive into this, I got one other comment here from Edwin that he is confirming that SQLite triggers, I guess he's saying, can affect tables in other databases, but only if the other database is attached beforehand. So there you go. I think someone had asked about that earlier. So foreign keys, like I said, by default, not enabled in SQLite. And what is a foreign key? Well, it requires related keys to match the keys in another table. And as I continue to mention, this is not enabled by default. There's the official doc page at the SQLite site. And here's an example of how you can set that up. I have 2 tables here. I have the team table and the player table. And the player table has a reference to the team table in that you specify the team that the player belongs to. Now, normally you'd create that by having, a key. Here I have it as team ID in the player table is set as integer. But at the bottom of the create table player, you can see there's a new thing called foreign key. And I'm saying that the team ID column references the table team and its ID column. Now this means that I won't be able to insert into the player table team IDs for teams that don't exist. We'll look at this in actual SQL in a minute when we get to the demo part, so you can see an example of what that is. But this, essentially, foreign keys are incredibly helpful to make sure that you don't create bogus data in your database. So if you have 10 teams available and say they all have primary key IDs of 1 through 10, and you go to insert a player, you don't want to be able to insert a player with a team ID of 99, for example, because now you have what is called orphaned player data. They're not associated to a team. That's not really what your data structure is defining here. That's kind of a bad thing. And with foreign keys, you can prevent that from happening, because if you tried to insert the player with, say, the team ID of 99 when there was no team with ID 99, you'll get an you get a database error back that'll tell you, hey, that's not allowed based on your foreign key constraints. And like I said, we'll look at that in more detail in a demo in a moment. And Paul is asking, not me, another Paul in the Q&A window here is asking how to access the user version programmatically. I did kind of mention that. You would just, in Xojo anyway, you would just issue an SQL select, and in the select for the text, you would just say Pragma space user underscore version, and that'll return a record set with the value. All right, and Steve is asking regarding foreign keys, how does the deletion of a team for which players still exist, how would that work? Offhand, I don't remember what SQLite does for that. That kind of databases often do things differently with that. Some databases might automatically cascade down and delete the players. Some would tell you can't do that because you have players. I don't remember what SQLite's default is. So again, you'll have to refer to that page to see with what they have there. Odds are one of those two choices is default, and odds are that you can change how that behaves using a Pragma or something else. And Edwin is asking for clarifications when using Pragma with Xojo, whether you use SQLite or SQL execute. And the answer is yes. I always like to say that when people ask or questions, but it's both. If you just need to set a Pragma, you can use SQL execute because you're not expecting a result back. But if you need to get the result of a Pragma, you use SQL select, and then the result will be in the returned record set. All right, full text searching. Full text searching provides a smarter way for you to search text that's in your tables. Starting with Xojo 2016 Release 3, the latest version of FTS, FTS 5, is now included. Which is cool because it has some new features, which ranking is nice, and it also has the ability to highlight the search results, which is also nice, so that you can make it clear where in the returned text your result was found. There's a very long and detailed, well, actually, here is not the long and detailed thing. There's a summary here in the Xojo user guide and how you can use this. We'll look at an example here in a bit as well. And there's also a very long and detailed page on the SQLite site that you can refer to that I think is linked from the Xojo user guide. And to use full text searching, you create these things called virtual tables. And they're kind of a weird name because they're not really virtual. I mean, they do exist in the database, but that's the naming they have, so be it. And you create it and you tell it which version of FTS you're using. There's no real reason to use anything less than FTS 5 if you have FTS 5 available to you because it's a bit nicer. And so you create your table. That's what the first line does. And then you'll need to populate it with data. And typically what you're going to do, because the FTS table is not going to be a primary table. You're not going to relate to it. It's not part of your relational design in your main database. You're always going to get data from other places of your database and populate the FTS table. So that's what the second line here, it's inserting a bunch of data from a book table. And then you use the match keyword. So you just select from your FTS table, but you use the match keyword and you can tell it to order by rank, and that's it. It'll just do a smarter searching of data. The match keyword will check all the columns that are in the table for you automatically, so you don't have to write all that SQL. It'll be smarter matching, so it's not as if you were using the like command with wildcards. So it'll actually find things that have the word cat in it, as opposed to text that starts with category and stuff like that. So those would be ranked. It might still find those, but those would be ranked lower. And then the last SQL that you see here also makes use of the highlight function, so that if something gets found, it'll highlight it in the little brackets here, so you can see it in the returned results. And again, I've got an example I can show that will show some of this and how the results look. Indexing is another thing to pay attention to when you're setting up your SQLite databases. And an index can improve the performance when looking for data in the tables. This is probably the primary use for indexing. You can also have an index that, what's called a unique index, that enforces uniqueness in a particular column, like, say, a primary key. That's not as common a use of indexing, but I suppose it depends on how your database is set up. And you can index single columns or groups of columns. And the best way to improve your performance is to index the columns that are commonly used in your where clause. And then also to only index columns in tables that contain a lot of data. There, if your SQLite database is small, and you'll know small just based on your app or whatnot, but if it's small and the queries are returning back, quickly or almost instantly or something like that, you're really not going to need to worry about indexes and have to deal with them. But if you end up with, hundreds of thousands of rows and queries perhaps are taking longer than you want them to, you might try some indexing on some of the columns you're using in your queries to see if that can help improve things. Now, it's important for me to stress that you don't want to over-index. Like I said, if your database is small, don't bother with indexing. Really, that's not going to help you. But if your database is large, don't think, well, I'm going to nip this in the bud. I'm just going to index everything, so I don't have to worry about it. Because that's bad as well. If you add indexing, that adds size to your database. SQLite has to store data to track this stuff, and if you index everything, that's increases the overall size of your database. It also can negatively affect performance because whenever data is inserted into a table, the index needs to be updated. And if it turns out that your app is designed to do a lot of inserting and you've put a bajillion indexes in places, all of a sudden you could find that part of your app, the inserting of data, really slows down. So again, you have to test, try things, see what the result was before and what it is after, and make sure you're getting the improvement you want. But indexing can certainly help quite a bit. Creating an index is generally pretty simple. You got to give it a name. You tell it the table and the column or columns that you want the index to be working on. And how does an index get its speed? Well, you can its name kind of implies that, but if you don't have an index and you need to search for something, generally SQLite is going to have to just scan the table, from the beginning to the end. And that's not super efficient, but an index allows those type of lookups to just happen much, much quicker because it can jump right to where the data is. All right, let me see here. Edwin is asking about the previous thing, the virtual tables with the full text searching. And he's asking if it's like a view or is the data actually duplicated in the database, or is it more referenced? Is it like a view or is the data actually duplicated? And, I don't know technically what happens behind the scenes. I suspect the data is duplicated just based on my usage of it and how it has to search through it. But I haven't studied the implementation details to see how accurate that might be. And Edwin, regarding indexing, is also asking if it makes sense to have an index on, say, 4 of 6 columns, or would that be considered over-indexing? And like I said, it depends on how those are used. A single index that has 4 of the 6 columns in the tables isn't really useful unless you often have where clauses that are also using the 4 of those 6 columns. As the index probably isn't going to get used if, say, you use only 2 of the 6 columns. So you may find that, you want to index the columns individually works better than indexing them in groups. Indexing fewer columns might be sufficient to cause the lookups to improve in speed because maybe they can pinpoint a subset of data more quickly, and then it can do a scan on the rest, and that is fast enough for you without the extra space of maintaining more indexes. There's no real hard and fast answer. It depends on the data, what's in the data, how it's distributed, how you're using it. Lots of factors. You really have to try them, test before, test after, see what the differences is, that sort of thing. Steve is noting that SQLite has an explain keyword that can help you kind of analyze this a little bit. And essentially, you just put the word explain right in front of your select statement. And instead of getting the results of the select statement, you get back this internal structure of how SQLite's processing the SQL. Steve's thinking that it can be helpful to people to pinpoint whether indexes are providing any benefit. I find the results coming from explain to be a little hard to decipher, but I bet there is the information in there to tell you if indexes were used when the query was run. So that can be another tool in your toolbox to help you identify if indexes make sense in your situation or not. All right. The next thing we want to cover here is BLOB. And what's a blob? That's kind of an acronym. It stands for binary large object. And that is essentially a big chunk of data. SQLite does have support for blobs. Whether you should use them or not is a little bit of a philosophical thing. Some people maintain that it doesn't make a lot of sense to store large binary things inside of a database. Maybe just keep those in the file system instead and have the database point to where they are in the file system. That can work. SQLite also has the support to let you throw these binary things in the database if you want. Also, Xojo has the ability to incrementally read and write the blob data, which can be helpful for getting stuff in there more quickly. There's a SQLite blob class that helps with this. That's the doc page there. I think I got an example here. We'll quickly look at what that does for you. And like I said, whether or not it makes sense to store large chunks of data like that in your database, I mean, if you're going to do that, you want to design it carefully. For example, you may not want to have the blob data be, a column on a commonly used table. That could possibly slow down queries on that commonly used table. So you may instead want to have a separate table that is related to the commonly used table. And the separate table is only job is to contain this blob data, and then you can just join to get what you want. That's a common technique. Other common technique, as I mentioned, is just to keep the stuff in the file system and save a reference to it so you can look it up there. Again, depends on what you're trying to create. The benefit of putting it in a database, of course, and in particular with SQLite, is it makes it easy. If you need to distribute stuff, everything's all in one SQLite file. Granted, if you put in a lot of binary stuff in it, that might be a big file, but at least it's all in one place so you can get at it more easily. All right, now we're going to switch over here and look at a couple of things in particular. All right, here I have a very simple SQLite database set up. This is the Eddie's Electronics SQLite database that we often use with Xojo. There's actually a Xojo app that can be used to show and work through some of the data that's in here. And this primarily has customers table and products and invoices and stuff like that. And I've also added a player and team table to test foreign keys. So if I look at the customer table, I just want to point out here, there's trigger that is on here. You can see that's the same trigger I had showed you earlier. And you can see here on the N is the full name column. And if I modify one of these names here, I think I may have to commit it and then reload it. You can see the trigger ran and it now updated the full name column here. All the others are blank because I actually added this column after the fact. This is not technically part of the official Eddie's Electronics database. So because I added the column after the table already existed, it was null by default. And now because I only have the single trigger, it will only update when I modify a particular row. Now I could, of course, as part of my database upgrade script, if I had such a thing, I could have altered the table to add the column, and then I could have issued a single SQL update statement that would just go through the whole table and update the full name column using whatever values are in first name and last name. Kind of a one-time shot so that the data is current, and then the trigger could be put on there so that any new data that is added or modified continues to stay current. So that's how you can use and take advantage of triggers. I also put an index on this column here on the last name column. Unfortunately, Eddie's Electronics doesn't really have enough data to benefit from indexing. So it's not like you can really see any difference in the speed of query results as to whether the index is here or not, but you can easily add them to tables. Now, when you open a SQLite database, by default, as you can see here, the foreign keys Pragma is off. So I can turn that on. And then now we can see that this is enabled. And I have here the team and the player tables that I showed you earlier. You can see here the player data structure. And let's open up team. You can see we have one team in there right now, the Red Sox, with an ID of 1. So say I want to add a player to that team. So I could give it the team number. Now that obviously will work because that's the team number, but say I decide to make that 100. When I run the SQL, I get the database error back that says the foreign key constraint failed. And that's kind of a good thing because that means we're not creating invalid data in our database. And then if I put the correct value in there, then you can see the insert correctly updated. And then now the row is in the table where we want it. So foreign key is definitely useful. Larger database type servers, have this enabled by default. And so if you've come in from there, you're probably shaking your head as to why this isn't something that's automatically enabled in SQLite. But actually, it's only been added to SQLite fairly recently. Maybe not that recent now, but probably within the last 5 years. And I don't think they've reached the point where they want to just flip the switch so that it's on all the time. I'm not sure why not yet, though, but I'm sure they'll get to a point where they want to enable it. All right, and before we jump into a couple of Xojo projects here, I see Steve has asked or noting that indexes can also benefit joins. And that's a good thing to point out as well. If you're querying data from the database, an index on a column that's used obviously will speed up the retrieval of that data. But if you're joining multiple tables together, an index could also possibly help in the lookups to do the matching between the two tables. So again, the important thing there is to note what might be, what queries are happening slower than you expect, time them, put some indexing on, time again, see if you're getting the type of difference that you want. Let's see here. Another question from Juan asking how to trap the error constraint that you got back from Xojo. So that error when we did the insert with the wrong team ID. And you would trap that the same way you trap any error. You would, after you call the SQL execute command, you would check the error property, see if it's true. And if it is, you check the error message property to see what the error is. All right, and All right, Douglas is noting here that SQLite does not have native column type for currency. So what's the best way to handle currencies for Xojo, or anything really that's stored in SQLite? Well, I didn't bring that up here, but that's worth a mention. SQLite's use of column types is different than every other database on the planet, and it's kind of weird. Because SQLite doesn't really have column types. It lets you name things with types, but it doesn't really enforce the types like most other databases do. So if I create a column type of integer or whatever, I could still throw some text into it, and SQLite really isn't going to care, which is strange. So by and large, it doesn't often matter what type you use for your SQLite columns. SQLite uses the term affinity for how the columns are typed, in that you might get slightly different behavior if you say that a column is an integer versus text if you use certain commands on it, but it doesn't prevent you from inserting one into the other. So I guess that's why they use the term affinity. So if you wanted to store currency data in SQLite, you can just write it out however you want, really. Options include you could write it out as a straight integer and then do the math to divide out the decimal portion when you pull it into your app. You could just use a SQLite double column, so it'll retain the decimal point. It's not really going to do much for you there. You could even store it just as text if you wanted, and write it out using the format, and then read it in and convert it back to currency. So it's not really a hard and fast rule. SQLite's not going to care a whole heck of a lot. When you get it in, you just need to throw it into the data type in Xojo or whatever language you're using, so that you can manipulate it as appropriate in your code. But SQLite doesn't really care. All right, the last two things to show here, I got two Xojo projects. So the first one is, of course, the one that's not on top. And this one is the full text search example. And I have here the database. I'll just click the search using that term, and you can see I got some results back. And the big thing you can see here is the search text is highlighted with the little brackets. And you can see that on the different lines. And that's pretty cool. Looking at this particular code here, you can see just created a very simple virtual table and then just populated it with some simple text. And if we go to the window, you can see the SQL statement, again, pretty much the same as what I had showed you earlier, with using the highlight function here to highlight the stuff with the brackets. And then you call it the same as you would any other select statement using SQL select, and then you process the record set, and in my case, you just display the results and it shows up there. But it's pretty easy to use. You just got to maybe remember that this is an option for you. And if you do have a lot of data in your database that you do want the user to be able to search, this can be a nice way to do it. And, a common technique when you're doing this is, you're copying data, as I mentioned, from another table that already exists in your database. And then also in the FTS table, you could include, say, the key, so that when you get your FTS search results back, you'll have the key available that then you can then use to go back to your real related table structure and maybe fetch the actual data out of there. So a lot of ways you can structure that, but that's how that kind of works. Right, and then the last example here is the SQLite BLOB example. And this here, I'm just going to pick a file. This is a 69 megabyte Xojo doc PDF. And open that. So that's now been added to the SQLite database. And then I could actually pull it out of the database as well. And you can see, well, this is the original one, and that's the one that just got exported. They're the same, of course. And so that allows you to, put data in there and get it out, should you want to do that sort of thing. This is using the SQLite blob class to create a blob on a particular column, and then reading through the binary data and then writing it into the blob. And then exporting is kind of doing the reverse, except it's reading all the blob data in and writing it out to a binary file. So not much different than working with binary data in Xojo in general. But if you do decide that putting binary data is important and you want to keep that in the SQLite database, you can use this class to help you out with that. All right, I got another comment here from Edwin, wanting to know regarding prepared statements for use with currency. Oh, when you're setting up a prepared statement and you're binding the values, currency is not listed there. Yeah, that's kind of a pain on the desktop side. It doesn't really matter on the iOS side because the types are all looked up for you automatically. You don't have to specifically bind the types, so it's a little easier to work with. I think double is accurate enough when doing the binding there, because again, I mean, on the SQLite side, it doesn't really matter. It's more that you're just telling it the data type from which it's coming from the Xojo side. So I think double would probably work. If you find it doesn't, though, my fallback for any time when the SQLite affinity types aren't working the way I want is to fall back to text and then convert it back in code. I want to thank everyone for attending. Have a great day.